Welcome on back, CPR for 1B. As promised, here is part 2 of our new stuff with square roots, 11.2 part 2. Okay, simplifying square roots this time with variables. Oh no, but it's going to be fine. Okay, really, it's the same old song and dance, only with another little twist thrown in. With these, okay, so let's just refresh ourselves. Imagine the x to the third isn't there anymore. We're just going to split it up as square root of 27. So remember, square root of 27, we want the perfect square part and the regular radical. If you're getting the hang of it, that's 9 and 3. Okay, square root of 9 is just 3, and we have square root of 3. Now I left myself some space because now we have the variable to talk about. Okay, with the variable, okay, x to the third, it's important to remember we're finding the square root, okay? So that means we want to know how many pairs in this case of x can come out of the radical, okay? So if we imagine this x to the third as x times x times x, okay? Imagine this as a sock drawer almost, okay? I have 3 socks, boop, boop, and there's another one hiding behind there, okay? How many pairs of socks could you bring out if there's 3? Okay, well, you would bring out these first 2, or maybe the last 2. But anyway, you can bring them out, and that would be 1 pair. Now, what that would leave you with is a straggler behind. So in this case, our answer is that 1 pair that we brought out and the 1 we left behind. So it looks redundant, but it is a little different with the square root and stuff in there. So 3x roots of 3x. Okay, so how many pairs can you bring out? The next example, 245x to the third. So 245, break that up just like we did before. Let's find the perfect square radical. With the 45s, anything that ends in 5, I like to always try 25 first. Now, of course, that one doesn't work. 245 divided by, I think 9 goes into it. Then why did you try 81? Okay, no. 245 divided by 36? No. Do you guys find it already? 49 and 5. There we go. Square root of 49, square root of 5, and we have the x to the third part to worry about later. 49 is 7. Root of 5 does not break down. How many pairs, if there's 3 socks, can you bring out? I could bring out 1 and have 1 left over. Here's a little hint for you. If that number is odd, there is always a leftover. Okay, so if it's 7, if it's 9, if it's 11, there's always going to be a sock left over, so to speak, in your drawer. Okay, 7x, root 5x. Alrighty, let's take another look. Oh, 2 variables, and let's make this y to the 5th. All right, so change it up a little bit. First, let's take care of the 32. 32. Now, here's a common mistake. So I know 32 is divisible by, so 8 and 4. Okay, some students write the 8 first, then the 4, and then they break it down. They're like, oh, that's 4 maybe. No, that's not the proper way to go about it. Remember, you want the perfect square first, specifically the biggest one. So the biggest one that goes into 32 is actually 16. And it's 16 times 2. Okay, so 4 and 8 would work. 16 is bigger. So we have the square root of 16, and that is 4. Roots of 2. X. So how many pairs of x can come out? 1, and we have 1 left inside. Okay, y. How many pairs of y? Another way to think of it is kind of like division. If you take 5 divided by 2, okay, that's 4 with a remainder of 1. So that's 2 with a remainder of 1. 2 goes into 5 twice. So it would be y squared and then y. So the number inside is kind of like your remainder, and this is how many times it goes into it. Okay, 4x squared, or 4x y squared, and all that there. If, so I know someone's probably like, well, isn't this the same thing as 4 and 8? Yes, it is. Okay, 4 becomes 2. Now remember, 8 could be broken down more. It could be broken down into the square root of 4 times the square root of 2, which is another 2, hence the 4. Okay, so you want the biggest square that goes into it. Okay, last example, m squared n, 343. Let's just try it out. Okay, so let's find the biggest square. Goes into 343. I've done it a few times, so 49 and 7. Okay, 49 just becomes 7, and then we have a root of 7. Now think to yourself, how many pairs if there's 2? Well, that's just 1. You can bring out a whole pair, and there's nothing left. So if it's even, there's no leftover. Okay, and on the other hand, you cannot bring out a pair, so it's just going to stay inside there. Okay, 7m, roots of 7n. All right, so with variables, how many pairs? Pairs, think of it as a sock drawer, anything you can bring in pairs of shoes, anything like that. And try out these problems as part 2 of the first section.